Consider the function given here. It is a rational function with a linear over a quadratic. Find the equations of all asymptotes. So vertical asymptotes, as always, occur as when the denominator, which in this case is x squared minus 3x minus 4, is equal to 0. Given that is a quadratic equation, we need to solve the quadratic equation, which we're going to do by factorizing. We can see that it's minus 4 plus 1, which means we have two vertical asymptotes, so x equals negative 1 and x equals 4. Horizontal asymptotes are what happen as x tends to infinity. Now, as x tends to infinity in this case, what happens? Well, in the numerator, we have a linear power of x, so that is infinity. But in the denominator, we have an x squared. Let's think about what happens. 2x minus 6 tends to 2x. X squared minus 3x minus 4 tends to, well, as x gets absolutely massive, this minus 4 is inconsequential, but this 3x is also not particularly important. When you have 1 billion squared, an extra 3 billion is actually not very large compared to 1 billion squared. So that bottom one tends to just x squared. That simplifies down to 2 over x, and as x tends to infinity, that tends to 0 because you've got 2 over a massive number. So our horizontal asymptote is y equals 0. That is always going to be the case when you have a linear over a quadratic, because you're always going to get this linear thing that is getting big, but it's not getting as big as quickly as the x squared part of the quadratic. So you're always going to get this thing with something over x, and that is always going to simplify down to an asymptote of y equals 0 for this type, where it's a linear over a quadratic. Find the axes intercepts. So let's first of all think about the y-intercept. The y-intercept is when x is equal to 0. So we substitute in y equals minus 6 on the top over minus 4, which is 3 over 2. So our y-intercept is 0, 3 over 2. Our roots are when y is equal to 0. So that is when 2x minus 6 over x squared minus 3x minus 4 is equal to 0. But when a fraction is equal to 0, it is when the numerator is equal to 0. So 2x minus 6 is equal to 0. So 2x equals 6, x equals 3. So our root, our one root is at 3, 0. Now let's put all of that into a graph of this function. For my axes first of all, nice and big so I can see the whole of this graph. What's going on? First of all, let's go back to my asymptotes. So I had vertical asymptotes at minus 1 and 4. So I've got a vertical asymptote at minus 1 and at 4, which is approximately there if I'm using a constant scale. I'll put x equals minus 1, x equals 4. Now my intercepts, my y-intercept was at 3 over 2. So that's about here. Let's go with about there. And my x-intercept was at 3. So about here in relation to that 4. Now I've got to think about what does this graph look like. So in the middle, we can probably see what's going on because it's got to go through these 2 points. It's got to approach these asymptotes. It's got to come down from here, go through there, and then go through that one, and then bend back down towards that asymptote. So the middle section works quite well. We can work that one out. But what about these 2 sections? It's not clear. We know there's no root, so it can't cross the axis. So it's either going to be like this, or it's going to be like that, but we don't know which one it is. Similarly over here, it's either going to be like that or like that, but it's not clear. Now the way we're going to do this is using what's called a sign diagram. So a sign diagram is thinking about what's happening in each stage. So our original function was 2x minus 6 over x squared minus 3x minus 4. Now let's think about what happens at different points on this graph. So let's think first of all in this section here, when we're less than -1. So let's choose something like -10, some point over here. We're going to get -20 minus 6. Now that is definitely negative on the top. And we're only interested in the sign. I'm not interested in the value, just the sign. On the bottom, I've got, so minus 10 is going to give me 100 plus 30 minus 4. So that's going to give me a positive number. And when I put those two things together, I've got a negative and a positive. That means that when I do that division, I'm going to get a negative answer. So what that means is this function is always negative on this side of -1. So that now means I know it's going to be this type over here because it's always going to be negative. I could do something similar in here. For example, in this section here between the asymptote and 3, if I wasn't sure where it was going to be, I could use 0. That's going to give me a negative on top and a negative on bottom because we get -6 over -4. So this one is going to be positive, which is why it's always above the axis. Between 3 and 4, I could do 3.5. So I get 7 minus 6 is going to be positive. And then this one's a bit trickier. I'm going to have to do 3.5 squared minus 3 lots of 3.5 minus 4. Well, that's pretty likely it's going to be negative, and indeed it is. Positive divided by negative gives me the fact that this bit here is negative. What about this last section? Let's choose a number bigger than 4. Again, 10 is a nice easy one to multiply by. Get 20 minus 6 is positive. And then 100 minus 30 minus 4 is still going to be positive, so that one's positive. So positive divided by positive means in this bit here, it's always positive, which means it's going to be this kind of graph. So there is a little extra step with these ones where you have to sometimes think about the signs. Now you might not need to write this out. You can probably do these bits in your head, these pink bits in your head to work out where they're going to be. But you do need to go through that process to check where they're going to be when you don't have any roots to tell you which side of the axis it's going to be on. But there we have our graph. We have our y-intercept, our x-intercept, and our two asymptotes labeled, and our graph split into 3 parts for this linear over quadratic function.